have pinned the presentation in the chat. So if you would like to follow along or have that for access later, it's there. So good afternoon, everybody, and welcome to, I'm really, really excited about this, our very first Math Fluency PLC of this school year. I was expecting a much larger group, but I know we have a storm coming, so perhaps some people are preparing for that, and hopefully it's not too bad here. So anyway, I'm really excited about this. I'm going to be learning right along with you as I am looking to strengthen my fluency knowledge. And I like for all of my PLCs to be a collaborative space and a space for sharing. So if you have some ideas, feel free to raise your hand and chime right in, and I'll be sure to call on you, and we'll have a great conversation, especially since we're a small group today. No worries about doing that. All right. Okay, so just a quick check-in. I know we've got a lot going on here. We've had a busy week, a busy full week. We've got a hurricane or some remnants of a hurricane coming, tropical storm, whatever it is. Where are you on the scale of sheep today? This can be personal, this can be school related, no judgment. Just type in the chat where you are on the scale of sheep today. Check in with yourselves, and we'll check in with others. Nine. Oh, Dion's excited today. All right. 2. I love number 3's hairdo. Number 5, sleepy. Definitely teacher tired, right? Your grandbaby's on the way. Congratulations. That is awesome. Now, where does the grandbaby live?
Hey, so they're here. So I'm actually going to be in the delivery room. It's our first grandbaby, my son and daughter-in-law. So I'm extremely excited about that. And plus track out starts next week. So it's perfect.
Oh, is the baby coming next week? Not like not
no,
like
no.
today. Okay.
No, she's in labor. She's going through labor right now, and if she doesn't come before Saturday, they're inducing her Saturday. So the baby will be here this weekend, and then I start track out Monday. So
super convenient, man. Great. All right. Anyone else want to share or unmute and share about how they're feeling today? Or drop in the chat how you're doing on the scale of sheep. Okay, so I see people are popping in. I certainly, anytime you all are a few minutes late, that is perfectly fine. I share the presentation. I know you have duties. I know the buses can be unpredictable some days, so feel free to sign or join us anytime. And if you ever need to miss one, we award credit for those who attend most. All right, so just to kick us off today, we're gonna take a look at this really quick video.
Mommy, I'm not going back to school anymore.
Why not?
Because my teacher said on Monday 4 and 4 makes 8.
Okay.
And then on Tuesday she said 6 and 2 makes 8.
Okay.
So today she told us 5 and 3 make 8. So I'm not going back to school until she makes up her mind.
It would do that to me right at the end, but did everybody catch that? I'll do it one more time. I see some people are joining, so maybe this time we won't have the skippies.
Mommy, I'm not going back to school anymore.
Why not?
Because my teacher said on Monday 4 and 4 makes 8.
Okay.
And then on Tuesday she said 6 and 2 makes 8.
Okay.
So today she told us 5 and 3 make 8. So I'm not going back to school until she makes up her mind.
That is super cute, and I love it every time I see it. But how many of you think our students can relate to that? Just these math facts are coming at us, and you know, hey, yesterday you told me 4 plus 4 gives me 8. Tomorrow, you know, you tell me 5 plus 3. It's very confusing when our students hear that from us just as rote facts. And sometimes they rote memorize them without any kind of meaning
Mommy,
behind them.
I'm not
And it can be very difficult for them. Okay. Sorry, I didn't mean to play it again. All right. So what we're going to do today, we're going to play a little Kahoot, which is going to serve as our anticipation guide. We're going to watch some fluency videos from students and a video about what fluency really is. And then we're going to kind of dig deep into this question of why do we want our students to be fluent when everybody's got a calculator these days? Where does it matter for our students to be fluent? We had a very brief training this week on our learning model, but we want to do everything, consider everything that we are doing in our PLCs with our learning model in mind. And hopefully we are gaining some knowledge from this to give our students some of the high impact instructional strategies and some well-being and resilience in their math knowledge. And of course, we're moving along with that standards-driven instruction. Okay, so our desired outcomes, we want to understand what fact fluency means. And then I'm going to give you a little bit of an understanding of the fluency progressions. And then we're going to talk about what we're going to do in the next PLC. Okay, so if you can go to kahoot.it on your laptops or your phone. And I'm going to share this screen as soon as it comes up, and we're going to play Kahoot. Now we're not going to have a winner. I'm going to make everybody have anonymous names, so we don't know who you are. This is just for your personal knowledge. Okay, there's your game pin. And I was going to set it to where we have anonymous names, but maybe that's an upgraded feature now. There we go. Okay. Once you go in, it'll generate an anonymous nickname for you now. Then. Everyone familiar with how to join Kahoot? You'll go to kahoot.it, and then you will put in the code, and it will give you a name like Fuzzy Bunny or Rational Pony. This is great. I'm going to step away and get my water, and I'll be right back. It's just red. Okay, for the sake of time and the Kahoot music, we're going to go ahead and get started. That music drives me nuts. Okay, so these are going to be all true, false questions. All you have to do is hit true or false. Number 1, memorization means fluency. True or false? All right, awesome. Yes, that is a myth we want to dispel. Just because you have a good memory does not mean you're fluent. If you are as old as I am, you were probably forced to memorize your facts, and they were just rote memorization without any strategies to figure out what you may not know. So fluency is not memorization, and this is something we'll look at throughout this PLC. Okay, speed is the most important factor. Speed is the most important factor in fluency. Nice. Yes, speed does not equal fluency. At one point, I think we were told something about count to 3 in your head. They need to answer it that fast. We're going to have a discussion about that. Speed is not the most important factor. Next question, time tests improve fluency. So, in researching this question, I have seen some research that supports time tests and says that they're rather important as students build fluency. However, is you want to have it does not provide any kind of practice throughout fluency. It's just a way to measure it. So it's just a data point. It's not something that necessarily improves fluency, where there's some other research to say that they do. I blame my teachers. Oh, it's really raining. Okay, I blame my teachers for when I was younger for saying, as soon as you're done with this, you can go outside or you can go to lunch or you can have free time. So, yeah, but I rushed through my work and didn't always check it. All right, all students learn math facts the same way. No, they don't. And we know that. We know all students don't learn, math facts the same way. They staring at flashcards, staring at a piece of paper doesn't works for some students, but not others. So everybody has a little bit of different way and a different little bit of a different learning path when learning the same number or specific facts in mathematics. And the last one, y'all see a trend here? Once fluency is achieved, practice is no longer necessary. True or false? All right. So yes, practice is always necessary once fluency is achieved, and we'll talk through that and learn some information about that throughout this PLC as it progresses this school year. So, like I said, the points don't count, so we're not too worried. But if you were a winner, you are being rewarded for your speed, not your accuracy, right? Okay. So yes, those were all false. Those are some of the most common myths around fluency. In fact, fluency that are out there, or things that we were taught as we were learning to be teachers or when we were learning to be students. So I'm going to let Christina Tonnevold, if you have ever heard of her YouTube channel, she is called the Recovering Traditionalist, but her company, Building Math Minds, actually offers some free math training every now and then. But we're going to look at what she says is the biggest conception about math fact fluency. And then I would like for you to share some of your thoughts when we come back together. I noticed some of you just jumped on during the game of Kahoot. So if you look in the chat at the very top, I did pin the Google Doc. Should be the first comment you see there, which is the slides that we're using today. So I'm going to let Christina Tonnevold talk to you.
Number 10.
I'm going to pause this for a second because she's got the skippies too. Okay, let's see if this helps.
Is a waste of time. People need to stop letting kids play and make kids memorize. Kids who learn strategies just take too long to solve problems when they
I'm going to try one more thing. Okay.
People need to stop letting kids play and make kids memorize. Kids who learn strategies just take too long to solve problems when they are older. Those are just some comments I get when I talk about focusing on building students' flexibility with numbers instead of making them memorize their facts. I'm Christina Tonnevold, the Recovering Traditionalist, and today I'd like to address the biggest misconception about math fact fluency in our quest to build our minds so we can build the math minds of our kiddos. Now, the biggest misconception is that how we teach fluency is an all or nothing scenario. People think that because I'm a proponent of letting kids play, that I don't think kids should practice and have repetition. It isn't an either or type of situation. It's a yes and. Kids need exposure to building their number sense and playing with numbers. And they also need practice and the solidification of those ideas so that they become more accurate, efficient, and flexible. I am all about letting kids play and explore with mathematics, but when we do only that, kids aren't getting the procedural side of mathematics. However, if we just do drill-based activities to make kids memorize their facts, the kids aren't getting the conceptual understanding. With this shift to the quote-unquote new mathematics, or whatever you want to call it, there was a lot of focus on building the conceptual understanding of mathematics, and the focus on procedural fluency kind of went away. If we don't find a way to balance that conceptual understanding with the procedural fluency, we will quickly see a call for the back to basics movement. And in fact, some places are already seeing this. It happens time and time again. The pendulum swings one way and that doesn't work. So it swings the complete other way, and soon we see that doesn't work. And then it will swing back the other way. If we want to stop this
I was going to stop about there anyway. So what are some of your thoughts about what she has said? Drop them in the chat or unmute. What are some things you might have heard other people say in regards to fluency? And what are some of your thoughts about her ideas? If you haven't been on a PLC with me, I'm really good at wait time. So let me pose a question. What were her ideas about letting kids play? Is that the only thing we should do? We should be doing? Should we only let kids play with numbers? Oh, okay. Thank you, Tim. For some reason, humans struggle with the both and. Yes, we want simple answers that are sometimes wrong rather than complex. So when we talk about, yeah, she says, oh, I let kids play with numbers, and people accuse me, all you want to do is let the kids play and not practice. But in fact, she does encourage both, right? Okay. Any other thoughts? I thought I heard someone unmuting, so I don't want to leave anybody out. And I know it was a little bit, that video was a little bit skippy, but we do tend to, in education, we tend to swing that pendulum one way. Oh, bad math scores, we're going back this way. And right now, if you look at a lot of our math curriculums are exploratory. We're letting our students find things out on their own, and there is some play that can be very important and can be very valuable. However, if we don't work in that practice with fact fluency, it really affects our students a little bit later on. Okay, so today, if you all have not heard of ChatGPT, ChatGPT is a wonderful tool. Just don't tell your students about it. Or if you get some essay written that doesn't really match, they probably wrote on ChatGPT. But I asked ChatGPT to write an article about Hurricane Helene. Well, it wrote because that's what's happening right now. But it wrote an article. Go ahead, Ms. Frank.
I'm sorry, that was an accident. I'm sorry.
Oh, okay, cool. Thanks. You're welcome to share anytime, no problem. So it wrote an article about a Hurricane Helene that happened in 2018 and didn't have a big effect. So I want you to read this article, and I asked it to leave 10 things blank. And in your mind, I want you to read it and see if you are able to fill in the blanks. Okay, go ahead. Just with a raise of hands, how many of you were able to fill in most of those blanks? Someone unmute or put in the chat why you were able to do that. Because most of us were. Why were we able to do that?
Hello.
Hey.
Hi. It just kind of makes sense to me, especially the first part. I'm like, oh, this just made sense to me.
Okay. Yeah.
Like
Dion
with the
says,
I would say a tropical storm. I would just say it something like that.
yep. And Dion says previous knowledge. Yeah, and we know we're familiar with vocabulary surrounding hurricanes. My goodness, this is what the third one we've heard about. We've heard about hurricanes all year long. If you were to present this for your students, chances are they will be able to fill in those blanks because they have some previous knowledge about hurricanes and they're able to make those connections. My memory is growing short these days, but was anybody in the fluency training yesterday with our math fluency frenzy with Dr. Cindy Washington? She said one of the most important things for our memories or our understanding or fact fluency is to make those connections. So, oh, yep, some of you people might have been there when it happened. That's true. Thank you, Nicole. Yeah, and we're able to fill in most of the blanks, and probably we could probably go back if there were some we struggled with. It remained open water for most of its lifespan. The hurricane posed minimal threat. We're able to fill those in because of the things we know. We've heard about hurricanes on the news every time I turn it on today. So we're able to make those connections, and we want our students to become familiar enough with some math facts that they are able to make connections to doing higher level facts and improve their fluency. So I'm going to show you, and I'm not going to play these videos on the slides. I got them queued up somewhere else. So maybe we won't have skips. But I'm going to show you Karen, and I'm going to show you Gilberto. And I want you to take some mental notes about how they use different strategies. They're going to be asked a question. The videos are rather short. They're going to be asked a question, a math fact, and they're going to give an answer, and then they're going to ask how they solved it. And just take note of the differences that they use in strategies.
Equals 12 because I know that 8 plus 2 equals 10 and there's 2 from the 4 and there are 2 left and that equals 12.
Okay. 7 plus 8.
That equals 13 because I already know that 2 times 8 equals 16, so we took away 1 equals 13.
Okay, nice. 8 minus 2.
8 minus 2, 6.
How do you know?
Because I know that 6 plus 2 equals 8, so we take away 2 and that equals 6.
Okay. 16 minus 7.
9.
How do you know?
Because I know if we took away 6 equals 10 and then it's the 1 more 2
internet must be bad in this room I'm in, but I'm going to share Gilberto with you. And you're going to just kind of see what types of strategies he uses.
4 plus 8.
12.
How'd you know that?
Because you just added 2 and then the 2 again.
Okay. 8 plus 9.
17.
How'd you know that?
You can take away 1 from the 8, and that would be 10 for the 9, and then add 17.
How about 12 minus 3?
9.
How'd you know that?
Because 2, and then you take away 2 and then 1.
Okay. 16, take away 7.
9.
How'd you get that?
Because it has 6, and that equals 10, and then 9.
Okay. Since it doesn't like me, I'm going to stop there. What were some of the things that you noticed about the differences in strategies? What was Karen doing as opposed to what Gilberto was doing? Sometimes they use something very similar, but what was she doing? Yes, I'll take care of it. Thank you. Karen was using something as a benchmark. What was she using as a benchmark in there? She was using 10. She was using 10 as a benchmark a lot. And she knew some facts. And it looks like, thank you, Mason. And it looks like she really knew her facts to 10. Because she mentioned that a couple times. What did you notice Gilberto do with the, and I know how to stop it early, but what did you notice that Gilberto did when he was asked what 8 plus 4 was? What did he do?
I think he did 8 plus 2 plus 2.
Exactly. He broke things apart, right? He decomposed, right? Now, you are going to teach more than one strategy to your students as you're teaching fact fluency, right? You have your math talks. Why is it important that students are exposed to multiple strategies?
I think it's similar to when you have multilingual students and you're asking them to draw on all the knowledge that they have in order to make sense of what they're doing. So if you have, if you're able to hold on to certain pieces of knowledge from different areas, then you can draw on all that in order to come up with an answer.
Right. Good. Thank you. Thank you for sharing that. And is everybody going to use different strategies work better for others? Exactly what I was going to say. Thank you, Kelsey. Yes, exactly what I was going to say. Different strategies work better for others, and there's different learning styles. And when we have those number talks, it's very important that your students hear their peers talk about what strategies work for them, and they may think, oh, okay, great, that works for that might work for me. Or they're going to hear or sometimes they hear it better from a peer than they do from you. So she was using 10 as a benchmark. He was using decomposition. If you've had foundations of math with us, we teach a lot of different strategies. And some people actually come, especially with the subtraction piece that I do, sometimes people come away and they're like, wow, I'm overwhelmed. I don't know where to start. There's distance strategies and the number meeting in the middle and the number line and things like that. But not everybody uses the same strategy, and your students are going to find one that works for them. That's why we say with IEP goals, don't write, we'll use this, this, and this, and this to solve the problems, because students sometimes change strategies too in the middle of what they're doing as far as fluency is concerned. Okay, so here are the pillars of fluency. We want our students to be able to flexibly apply the learned strategies to new problems. So just like we applied our knowledge and filling in the blanks in the hurricanes article, we want our students to be able to apply what they know to new problems. So if Karen learned her facts to 10 really well, then she used 10 as a benchmark and knew her facts to 10, then when she's presented with maybe a 2-digit by 2-digit addition problem, she's able to add those very quickly because she uses that 10 as a benchmark in our base 10 number system. Efficiency. We want the time needed to solve as reasonable, but not super fast. So we're not counting to 3 in our head. We're not flashing the flashcard up and throwing it out if they don't know it. We're giving them a strategy, allowing for that strategy for the appropriate numbers and operations. And accuracy, of course, is the correct answer. And automaticity. Automaticity is important. It doesn't have to be 3 seconds, but we want some form of automaticity. And so the question comes is then, okay, why do we need all of this if everybody has a calculator in front of them these days? Well, sometimes your students are going to have jobs and they're not going to be able to have their phones out, or they're not always going to have a calculator on them. And I'll give you one example I saw. There was a young man who was in Math 1, and I went to observe him at his high school. He was not fluent in his multiplication facts, nor was that something that was ever worked on in any of his past IEPs. Multiplication at all wasn't. So when it comes to factoring, he's sitting here with this factoring sheet in front of him. He's got a calculator over here. Do you think that calculator helped him factor? If ChatGPT would have, right? But no, that calculator did not help him one bit with factoring, because he needed to apply his knowledge of his multiplication facts in order to factor. So because he didn't have any or had not learned any strategies, or had not become proficient in even just some, facts, factors 1 to 9, he was having a very, very hard time factoring. And of course, in high school, we don't always have a multiplication chart. Kids don't always want to get one out. And that's something we'll talk about, using a multiplication chart and how that can be valuable in one of our PLCs as well. Okay, so why should they be fluent? Same for this little fella. He could solve the more complex problems effectively. Your brain can only hold so much at one time. So if your brain has to figure out what you're doing in the middle of this long, complex middle high school math problem, and you stop after a few steps, you got to think about what 9 times 2 is. Then, you're counting, and then you forget what you did over here because what you were doing, you had to stop and really think about, or use some other strategy to figure out what 9 plus 2 was. So it can throw you off. It can throw students off. They're better solving word problems, learning new concepts, transferring procedures, and applying the strategies in multiple situations. And of course, it builds confidence. And like I just mentioned, there's less time grappling with those facts. What questions do you all have so far? And please, like I mentioned, I'm learning right along with you. So if I'm not making sense, or you want some clarification on something, I will do the best I can, or I'll do the best I can to find out.
Quick comment or question. Sometimes I feel like I almost feel like too many options might be overwhelming to my students.
Mm-hmm.
Can you speak to that, please?
Yes. So I would pick the ones that you are most comfortable teaching. 1 or 2 or maybe 3 strategies that you're most comfortable teaching. Because if you think about it, you're probably most comfortable teaching, or what you are most comfortable with using yourself, you're most comfortable teaching. Sometimes our students develop strategies, or they learn them from another place, from home or another teacher, and bring them in. But I would stick to teaching the ones that you're most comfortable with. Does that make sense, Ms. Frank?
Yes. Yes.
Yeah. Yes. So like I said, when I teach foundations of math, we teach using a number line. There's one called keeping the distance. And we go into the negatives, and people walk away after learning about 5 or 6 different new strategies, and they're going, which ones do I teach? Teach the ones that you're going to be best with, and then practice the others. And then throughout, as you become a little bit more proficient with understanding it yourself, you're going to teach it better to your students.
Okay, got it.
Thank you so much for that. Any other questions? Okay, so these are the fluency progressions. This is the elementary addition, subtraction, fluencies. And then down at the bottom, it kind of shows the progression of the facts. So I'm going to give you a moment to look this one over for addition and subtraction. And then as you're looking it over, drop some notices and wonders in the chat. What do you notice that you might not have known before, especially if you're a middle school teacher? What do you notice about some of the other grade levels? It's particularly too, I want to bring out to you, where do you notice standard algorithm comes in? And what do kids have to do as they leave kindergarten? So where does standard algorithm come in? And then what do students have to do when they leave kindergarten? Yeah, can kindergartners have to compose and decompose 10? Then how far do they have to add and subtract? Yes, standard algorithms in 4th grade, and all they have to do is add and subtract within 5. So you elementary CCR teachers with goals, if you get kindergarten goals or they're adding to 10, all they have to do is add and subtract 5, but they want to have some of that number understanding, a little bit of place value understanding. Notice standard algorithm does not pop in there until the 4th grade. Then why in the world do some of us try to start teaching it in 2nd or 3rd grade? Now, actually, I do believe within 100 in North Carolina Standard Courses Study, I think 3rd grade starts working on standard algorithm there, and 2nd grade does use some place value strategies. But notice we teach in our progression, we teach kids to use strategies before we teach the standard algorithm. Now, of course, you know, if nobody balances a checkbook anymore, so as adults, we're not always going to pull out our base 10 blocks to balance our checkbook. That's wild, isn't it, Matrova? Yeah, interesting. So we're not always pulling out our base 10 blocks to balance our checkbooks, but we want our kids to use those strategies well, if that is their level of access. Now, you may have a 4th grader that you were teaching in your CCR setting who still needs to pull out the rods and the flats and, you know, cubes and all that. That's perfectly fine. But however, you know, we are meeting them where they are, but our goal is to ultimately move them into that standard algorithm. If you look at the bottom, I know it's kind of small there. We have the doubles. We've got the combinations of 10. Notice where it says foundational fact sets, and then at the bottom says derived fact sets. What are the difference between either known facts and derived facts? And if you notice, our students were doing that in the videos we watched. So if you notice with Karen, she knew her foundational facts. She knew facts to 10. She knew how to use 10 as a benchmark. But what she was doing when she got up into that like 7 plus 9, she was able to say, well, okay, I know 7 plus 10 is 17, and I take 1 away, and that's going to give me 16. So those are derived facts. That's the difference between your known facts and your derived facts. So we're not expecting our kids to memorize everything. Some of them like to memorize the doubles and use the, you know, doubles to find their near doubles, and the combinations of 10 certainly help. But these are the fact sets that you'll teach your students. Let's look at multiplication and division. Whoa, my goodness. Look at the algorithms here. Where do you notice the standard algorithm here? And where do students begin in 3rd grade? Yeah, notice that multiplication standard algorithm begins in 5th grade. 10 multiplication, that's where we start. 1 digit by 1 digit by multiple 10. Yep. And then we want them to eventually multiply and divide up to 100. So if you have a student who is in fifth grade, but doesn't have that understanding of multiplying to 10 or using the place value understanding, you need to meet them where they are. You're not going to try to teach the standard algorithm. You're going to teach those strategies like the partial products and the area model. We'll talk more about those in later meetings, but you're going to use those strategies to meet those kids where they are to develop proficiency. What do you notice about the foundational fact sets at the bottom? And which ones we should be teaching first? Meaning the ones at the top. 2, 5s, 10s. I used to tell my kids, if you can count by twos, because they did in kindergarten, whether they knew what it meant, they do it. They did it in early elementary school. I had middle schoolers that I would, what's 2 times whatever? I don't know, can count by twos? Oh yeah, 2, 4, yeah, okay, there you go. And they counted by 5s and they counted by 10s. So they just haven't translated that to their multiplication facts yet, right? So I always said, if you can know your zeros, 1s, 2s, 5s, and 10s, you can figure out anything else. Then we use those to figure out how to either break apart, subtract a group, add a group, to do the same thing with those derived facts. So gone are the days of memorizing your facts from 1 to 9s, or gosh, I think it was 1 to 12, and then you got more ice cream and more toppings for each fact set that you knew, or you got extra playtime, or you got a treat every time you learn one. Did that really help us? I had a great memory, and I could spit some information back out, but did I know what I was doing? Probably not. No, I didn't know how to use those. And a lot of students think about that. We get a lot of kids who can spit out some facts. I've seen some kindergartners come in and they're like 2 + 4 is 6 and this and this. Timetables, yes, timetables of multiplication. And it's to stress you out. You get up the front of the class and you'd have a multiplication bee. And if you didn't answer in a certain amount of seconds, you had to sit down. It's some crazy stuff. And then, of course, I did stuff like that, right? I try to teach kids the same way. But when we know better, we do better. So thinking about all of that, it didn't really help me. It was great to get the treat, but did it help me really understand how maybe I could use my 5s to figure out something else later? Nope, didn't help me at all with my derived facts. Just helped me spit information out. So as we move on, today is just a day where we just understand get a good foundation in what fluency is. And get your brains thinking about it. Maybe you want to go out and read some research and get some information on some fluency strategies to begin using. But there's number talks. If you attend, and I'm going to share a slide with you, but we do have our Fact Fluency Frenzy training. You will leave with a kit of your own that is either addition, subtraction, or multiplication, single digit, or multi-digit addition, subtraction, and multiplication. Those are great kits. They have number talks in them and they have number strings. And the training is excellent. And Tama put the link in there. I also have it in the slides, but there you go. It was great. We had a really good time training yesterday with the Track 1 PL Day. There's the manipulatives for reinforcement. Don't take them away just because they're in middle school or older grade. And don't tell kids they can't use their fingers. Your fingers are with you the rest of your life. And then manipulatives for reinforcement and reviewing the fact families, and part whole strategies. And then next time we're going to talk about incremental rehearsal. So if you want to look up some information about that, it is pretty cool. It goes off the basis that our brain can actually only learn like 3 things at one time. And we're guilty. I'm guilty of doing this when I'm even teaching adults, of throwing a whole lot of information out there. But our brain is really good, can learn 3 things well at one time. I remember I learned to play a song on the piano, and I could only learn it. Teach me 3 notes. And when I get good at playing these 3 notes, then I'll play another, another 3. That's kind of how my brain worked. So our brains are good at learning 3 things, but we're going to still practice those other facts, but implement learning and weaving in 3 new facts in increments for students to help them grow their facts. So a little change in the schedule. Our next meeting is going to be October 17th at 3:45. You will join the same way. And we're going to talk about incremental rehearsal. And where did my slide go? I think I hid it from myself, but we have a slide with all of our upcoming trainings on it. I will share that with you in just a moment. I will put that out there. But in the meantime, what questions do you have? Or comments or anything you'd like to share? Okay, there's.
I just needed a little encouragement.
I'm sorry.
I just need a little encouragement. Sometimes I feel like I see where my students are right now. I just need to know that if we do everything that we're learning in these PLCs and the resources that we've been provided, I can actually see students that are finding it very difficult right now to decompose a 10 to eventually get to that point. Have you seen it happen before? I just need to talk or touch.
Have I seen students become successful with learning to decompose 10s?
Yes. Okay.
Yes. I'll give you an example. I went out to give an NKT to a student who had come from another state. I think he was about 4th or 5th grade. And if you've ever seen the NKT, you have that, there's like, what's 47 plus 15 or something like that?
Yes.
And sometimes when kids are a little bit older and we're not doing this for data, I'll let them use, he was started to count. And then I was like, gave him a whiteboard. I want to see what he would do. And he was going to draw 47 dots and then 15 or whatever it was he was going to do. And I said, well, has anybody ever taught you another way? And he said, no. He lived in one's world. Is what we call that, one's world. So he was going to count. So what I went back to his CCR teacher and I said, he needs to go back to using base 10 blocks. So she did that with him. And she really built that foundation in decomposing 10s, 10 frames, and then moving to base 10 in the making equal exchanges or decomposing, regrouping. And the next school year, I came back in the fall and he brings me his work and is like, look what I can do. And he did that. So yes, it may seem like you are saying the same thing every day. It may feel like Groundhog Day, but there is value in teaching your students those strategies. Absolutely.
Okay. Thank you.
You're welcome. Any other questions or comments? This is our in the slides I've shared with you. There are our links and our numbers. If you've not registered for this Fluency PLC, make sure you do that. But if you're here, I'm gonna register you anyway. But like I said, you will be able to get credit, and I will share the recording out next. Usually, I share it on Mondays. If you are able to make it, we have I know I talked about foundations of math. We have I know we won't be able to make it tomorrow. We have a fall session beginning tomorrow, but we do have a spring session beginning as well. And we hope you all can join us. We also have our other PLC, which I had earlier this month, the schema-based instructions on word problems. And if you are middle school and you've not hit me up for hands-on equations training, whether you get it asynchronously or I come out to your school, please do that. So we will see you all again. There's our contact information, and I will see you again on October 17th at 3:45. Stay safe and dry and have a wonderful afternoon. Good.